when it's rotated around the center or the origin. So let's practice one. So we have A, B, and C here. A 90-degree rotation. We see that this point, the first thing we want to identify are points. So we start with 1, 2, 1, 2, 3, 4. 5, 2, and 1, 2, 3, 1, 2, 3, 4. 3, 4. 90-degree rotation. So we're going from A to B. Our relationship is negative B, positive A. Flipping the coordinates, kind of crisscrossing and making the first one negative for going to the left. So our A value, we start with 1, 2, will now be negative 2, positive 1. Here's A prime. Our B value, 3, 4, that we start with, will be negative 4, positive 3. 1, 2, 3, 4, 1, 2, 3. And here's B prime. And finally, C. 5, 2 will become negative 2, positive 5. And we're up here. So this kind of rotated 90 degrees. B is now pointing to the left, A is now pointing down, C is now pointing up. Next example. $180-degree rotation. Now I'm not starting in the first quadrant anymore. Rules still apply the same ways they did before with an 180-degree rotation. This becomes the opposite A value, opposite B value. So when we start, our A value, 1, 2, 3, 4, 5. Negative 5, positive 4. Our B value, negative 2, positive 4. Our C value, negative 2, positive 2. If this is rotating 180 degrees and going counterclockwise, we are now going to be in quadrant 4, down here. Following our rule, point A, instead of negative 5, will be positive 5, and it'll be a negative 4. Point B, positive 2, negative 4. And then finally, positive 2, negative 2. 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's A prime. B prime, 2, negative 4. Here's B. And C is 2, negative 2. You can see that, again, C is still kind of in the middle towards the origin as we wrap our way around. Still following this rule here. Now our 270-degree rotation. Now, this is going to be, again, a little bit different. As you see, 2 points are in quadrant 1. 1 point is in quadrant 2. They're still going to be moving 3 quadrants around. That'd be 270 degrees. And remember, this will now be a positive B value and a negative A value. So point A was 1, 2, negative 1, positive 5. B was 1, 2, 3. And we have 2, 1 here. So the B value of A would be 5. The A value, a negative of a negative 1, will be a positive 1. Remember, it's going around 90. 180, 270. We're going to end up in quadrant 1. Both things need to be positive. Part B, 2 and 3. The 3 becomes positive, the 2 negative. And finally, point C, 1 and negative 2. We'll be in the 4th quadrant as we're moving 1, 2, 3 quadrants over. So 5, 1, 2, 3, 1. Here is point A. Point B, 3, negative 2. And C, 1, negative 2. And there's a rotation moving around 270 degrees. Now, all of this is rigid motion, right? Rigid meaning that it doesn't change. And this is one of the postulates that we consider when we're kind of trying to prove different figures being congruent. And it's a rigid motion because it preserves the length and angle measures. So DE is congruent to D prime, D prime. The measures of the angles are also congruent, as we can see here. So because this is a rigid motion, the composition theorem guarantees that compositions of rotations and other rigid motions, such as translations and reflections, are rigid motions. So the 3 things that we talked about are all rigid. We keep the original shape of what we're doing. So the last one, we have a composition function, the composition of these transformations. We're starting with an endpoint at 1, negative 3. S is 2, negative 6 for that line. So the first one is a reflection in the x-axis, in the y-axis. So if we plot this, 1, negative 3 is here. I got room. Change this. And then we have a rotation of 90 degrees. Negative 3, here's R. And S is 2, negative 6. 1, 2, 3, 4. So we have this line. So the first thing, we have a reflection across the y-axis. The y-axis is right here. So the first movement, we're 1 unit away here, 1 unit away here. There's R prime. Here we're 2 units away, 2 units away here to make this S prime. There is our first movement, doing this step right here. Now we want to rotate this 90 degrees. So we're moving this from this quadrant to this one. So remember, our rotation is negative B, positive A. It's going to change to make this to come over here. So the opposite of 1, or the opposite of negative 3 is a positive 3. And then will be a positive 1. Whoops. Looking at the wrong one. I want to look at these points here. Sorry, I'm making a very easy mistake. Our new point here is 1, negative 3. Our new point here was negative 2, negative 6. So I need to change these numbers. So if we're looking at R, the opposite of negative 3 is positive 3. And the A value would be negative 1. So I go 1, 2, 3, and down 1. This would be R double prime. The S value, we're starting with negative 2, negative 6. So the -6 becomes positive. That's the B value. And the A value stays the same as -2. Down 2. And this is S prime. We have this translation, and this rotation here from this point here, swinging up here. So we started down here. Our first transformation was a reflection across the y-axis, and then we rotated here again. Take these slow, take these step by step.